Can everybody hear me? Hello everyone, it's now 3 o'clock. Good afternoon and welcome to this fourth webinar hosted by the Malaysian Water Association and Malaysia International Water Convention. Selamat Hari Raya to all our Muslim friends and colleagues, and we hope you had a joyous celebration with family and friends. Today's webinar is all about groundwater, and we have with us two speakers from NIRAS, Denmark, and one speaker from OCNED Water Technology from Malaysia. Our first speaker, Mr. Dennis Tan, Managing Director of OCNED, will provide us with an intro, followed by our second speaker, Mr. Mikael Jorgensen, Chief Consultant and Hydrologist from NIRAS, who is joining us today from Denmark. Michael's topic today will be groundwater, your goal, and your geology determines your strategy. Following that will be our third speaker, Mr. Berger Christian Blem, Senior Water Sector Engineer from NIRAS, also joining us today from Denmark. He will be sharing with us on Denmark's policy on groundwater. Well, I'm sure today, Michael and Chris woke up very early to prepare for this presentation. So we would like to welcome our three speakers and to thank them for taking their time to prepare for today's presentation to share with members and friends of the MWA. So halfway through this webinar later, we will be running a very quick survey and would appreciate if our participants can answer these three questions. It won't take up more than 1 minute, just a very quick one. And if you have any questions for our speakers, and I'm sure you will have a lot, because our past webinars, we received like a tremendous amount of questions to answer. So you may key in your questions during the presentation. So on your screen, at the bottom of your screen, you see an icon, Q&A. You can just click onto that icon and type in your question. Our speakers will answer your questions after the presentation. And some of you would like to watch today's session again. So this video will be streaming live on YouTube. And after the session, we will give you the details. All you need to do is to follow our Facebook page, Malaysia International Water Convention. So all information and links will be posted there. So perhaps I should now kick off today's session by inviting Yang Bahagia, Dato Engineer Abdul Kadir bin Muhammad Din, President of the Malaysian Water Association, to say a few words and to welcome everyone. Henny, you can on the video.
Hello.
Hi, Dato.
Okay.
You can
Okay. Thank you, Dennis, for the good introduction. Bismillahirrahmanirrahim. Assalamualaikum warahmatullah. Ladies and gentlemen, good afternoon and welcome to today's MWA organized webinar series. This afternoon, webinar is the third in the series and it's entitled Groundwater, your goal and your geology determines your strategy and the Denmark's policy on groundwater. I'm sure it's a very good topic. As we are all aware, Malaysia received abundant rainfall, averaging about 3,000 mm annually, that contributes to an estimated annual water resource of some 900 billion cubic meters. So it looks very big, but from this amount, about 43% returns back to the atmosphere through evaporation, 6% percolates into the ground, and the remaining 51% flows as surface runoff. So much of it going underground and subsequently flowing into lakes and rivers and on to the sea. Dams, pipelines, and irrigation canals built over the years have diverted water from these same lakes and rivers to meet the demands of domestic consumption, industrial use, and agricultural activities and also not forgetting the needs of life below water. So as of today, I would say that we have been blessed with sufficient water resources over the years, but now we have become a country faced with seasonal shortage of potable water. The situation has been further exacerbated by resultant pollution, affecting the ecology and the functional capacity of the aquatic ecosystem. Considering these factors, we must now change the framework of our water industry and look for alternative solutions in order to ensure the adequacy and reliability of our water supply. This webinar is expected to open our eyes to other sources of raw water, which is groundwater. So groundwater is often seen as a reliable source of clean water that is available at or close to the point of consumption, making it an ideal source for meeting the demand of potable water. As groundwater is found under the surface, stored in a geologic formation called an aquifer, it is an hidden asset and a very valuable asset for the future as well. Unfortunately, being a hidden asset, it is also out of sight and consequently out of mind. So it is estimated the groundwater constitutes less than 3% of the water supply in Malaysia, with the remainder sourced from surface water. Currently, the two states using groundwater in large amounts are Kelantan for its public water supply system and Selangor, known for its industrial use. Now, let us compare our groundwater utilization with other countries around the globe. Denmark has 100% groundwater utilization, Austria 98%, Thailand 80%, China 78%, USA 50%, but Malaysia less than 3%. Why is this the case for Malaysia? Groundwater resources in Malaysia face many serious problems that relate back to the absence of an adaptive and comprehensive management regime. So in a groundwater study by the Academy of Sciences Malaysia in 2009, among the major issues that must be grappled with in groundwater management are as follows. 1. Fragmented policy, legal and governance framework, pollutions, lack of sustained research and development, manpower and human resource issues, resource data collection, management and dissemination, and last not least, public awareness and stakeholders' participation. It is therefore very clear that Malaysia, to make use of its vast amount of groundwater, these issues must be faced with an effective and sustainable solution found. I believe that the prudent use of groundwater can meet the national requirements while reducing the impact of drought in the urban and the rural environments. Groundwater, if you look at it, is the best and cheapest alternative to surface water, which is facing huge challenges from contamination or pollution. Groundwater well fields can be created at the point of needs. Thus, we do not require long delivery pipelines, and this contributes heavily on the higher NRW rate. If you look at the larger network that you have, the more NRW rates that you will be facing. Groundwater treatment process is simpler and cheaper because it doesn't contain a lot of contaminant except for the natural minerals like iron and manganese. 97% of the world's fresh water is naturally stored under the ground. It does not have the same impact by dry water like the surface water do. Nevertheless, what is needed is a proper and good policy, regulation, and law on groundwater usage and strict control on its abstraction to prevent underground erosion, and also as what been happened in other countries who utilize water without any proper control. Plus, since this is groundwater is very precious, it is also necessary to look at the price of the raw water from the groundwater source for standardization. A careful study needs to be conducted to prevent any catastrophe on the abstraction of groundwater. And with this, it's my hope that the esteemed speakers from NIRAS, Denmark, and OCNED Water Technology Sdn Bhd will be able to shed more lights in the aspect of groundwater utilization, plus its management for water supply, and will help drive the decision makers to give more attention to development of groundwater resources in Malaysia for the near future, either to be as main source or to be a reserve source for the future. A big thank to you, to all participating in the MWA-MIWC webinar, and not forgetting Protem Group for hosting this event. And I wish all of you a fruitful discussion together. Thank you. I pass back to Dennis, please.
To all of you, and thanks Malaysia International Water Conventions for hosting this very timely webinar on groundwater. I'm here just to introduce a little bit of our background, the company background, as well as the speaker later. ONWATER is actually set up together with the NIRAS of Denmark, a big consulting firm who specialize in, among other things, specialize in groundwater. As you know, as what Dato say, Denmark is using almost 100% of groundwater for the domestic as well as the industrial use. So for ONWATER is set up through this kind of a program with DANIDA. DANIDA is Danish International Development Agency. So this is what the setup for the technology transfer. We grouped together in 2008 with Denmark through DANIDA program, through the Foreign Affairs Ministry for the technology transfer, whereby they come over here and train our people, and then we send our engineers there and geologists there to get the knowledge transfer over so that we can do this kind of projects professionally in our country.
Dennis, can you turn on your video, Dennis?
Oh, I'm so sorry. So sorry. Okay. So before I introduce our speaker, Mikael Jorgensen, that's why I just briefly introduce our company. This ONWATER and ONWATER is set up together with NIRAS since 2008. This is some time ago to do some projects in Malaysia whereby we do groundwater sourcing, surveying, then we do groundwater drillings and prospecting to development of groundwater utilizations. As you know, we are very much unutilized as far as groundwater is concerned. Only Kelantan and Selangor has utilized a lot of groundwater. The rest of the states are still very much untouched. And rainfall in Malaysia is almost 3,000 mm per year, whereby this is the recharge into the ground, and a lot of resources are there that we can for us to tap. So, but we need a technology. How do we tap? Where do we make sure we get it sustainability of this kind of water utilization? Okay, so before do not want to waste our time, I want to introduce our speaker. The first speaker is Mikael Jorgensen. Mikael Jorgensen is a chief consultant and specialized in the groundwater. He's also a hydrogeologist as far as this our country, our project is concerned. He's a project manager for many years in Malaysia. Of course, he have done job in 25 other countries from Europe, Africa, Asia, and Middle East. But he has been into Malaysia 10 years ago, and now he's also currently pursuing one of our project in Johor as a project manager for groundwater. He is with 35 years of experience in this kind of a field, particularly groundwater management, both technical, managers, and financial aspect of the groundwater project, whereby this is how he can contribute to our country on groundwater utilizations. Okay, so these are the specialized job that we do together with Denmark on groundwater, including treatments, from there, after treatments, when we do the distributions. So this is something that we have done, the job that we have done in Malaysia, like in Perak, in Selangor, Johor, and part of Langkawi as well, whereby we have done many groundwater wells and studies. Okay, So without further ado, I pass it to you, Mikael. Mikael Jorgensen's groundwater specialist, chief consultant from NIRAS Denmark. He's currently in Copenhagen now. Over to you, Mikael.
Thank you, Dennis. Can you hear me?
Yep.
Good. Thank you to Malaysia Water Association for inviting us for this presentation here. I shall put on my PowerPoint. Can you see my PowerPoint now?
Yep, Ken.
It's
Yes,
good.
we can see.
All right. So my topic is groundwater. Your goal and geology determines your strategy. And here's a short agenda. First, I will talk a little bit about typical project owners and their various goals with groundwater investigations. And following that, a short description, everything here has to be short, of course, due to time, but of some typical geological formations and their characteristics when it comes to groundwater. And finally, I will try to match the two and look at the way I see how the geology and the goal basically is the determining factors for your investigation strategy. There are many different project owners, potential project owners in groundwater projects, and I list a few of them here. National authorities can be project owners, state authorities as well, and of course regional water supply companies. What we also see in Malaysia and elsewhere, also in Denmark, is that various state-owned or private companies, could be hotels, industries, or in Malaysia, plantation owners or farmers. And finally, private residences, either one or a few house or a village, something like that. So there are many different types of project owners, and they would handle a groundwater project differently. National authorities would typically do a general mapping of groundwater resources, as we've done in Denmark. All of Denmark is mapped when it comes to hydrogeology and groundwater resources. Of course, as mentioned at the introduction by Denise, because Denmark is 100% using groundwater. It can also be mapping in water-stressed areas from national and state authorities or regional authorities. These kind of project owners typically go for a general mapping or to find as much groundwater as possible. But typically national authorities, for example, they leave the detailed mapping down to the well field level to the water supply companies, which are mentioned here below. They may do the same kind of general mapping, but would typically continue all the way down to well field level, and from there go into well field construction, design and construction. They may also, regional water supply companies, instead of mapping their whole supply area, they can identify resources to cover local demand. And as Dr. Kadil mentioned in the introduction, it could be a dry season supplement, because like in Malaysia, the problems are mainly seen in the dry season. So for regional water supply companies, it can either be as much as possible groundwater, or it can be looking for a more specific amount. Companies, state-owned or private companies, or farmers' plantations would typically look for a local water supply of a well-defined amount, what they actually need, but they may have different goals when it comes to water quality. I mean, like breweries, pharmaceutical companies, they may need a higher quality. And on the other hand, farmers would not be concerned of contamination when it comes to things like nitrate from fertilizer. That's only fertilizing their crops. So it's a different setup when it comes to water quality requirements. Private residences typically need quite a limited amount, but most private residences would want water that require very little or no treatment at all. So because a private house cannot do a full water treatment. So again, there could be different goals when it comes to water quality. So to summarize the different project goals, it could be to investigate large areas, or it could be more geographically focused. And quantity could be either as much as possible or a defined yield requirement, which could be high or low. And also when it comes to quality, there are different requirements where water supply companies typically can do full water treatment. Industries and private residences may have higher requirements and farmers lower requirements. So all this is necessary to make clear when you try to do your investigation strategy. Then when it comes to geology, basically it is really geology that determines aquifer properties. And here are some of the very kind of key properties of aquifers. First, they may be high yielding or low yielding. That's very obvious. And of course, that's an important way to distinguish between aquifers. Then they may be continuous, almost homogeneous, or they can have bigger lateral variations, or they can be discontinuous aquifers, where you only have water in certain zones and nothing in between. And then aquitards as clay may protect against contamination. And I will now show a few different types of aquifers. First, alluvium, which is also widespread in Malaysia. Here is a picture from Denmark of alluvium, and it can be continuous. I think in Malaysia, it is actually in areas in Kelantan, and it may have a high yield sand and gravel typically. On the other hand, alluvium can also be discontinuous aquifers. This here is an aerial geophysical depth slice showing the resistivity, the ground resistivity in a certain area in Malaysia. And you will see the blue areas are very low resistivities, 1 to 10 ohm meters as it's called. And there you will find nothing but salt water and clay in this depth interval, whereas the yellow and orange parts are sandy aquifers, channel structures that fill up of previous river channels. So in an area like this, you have to know the aquifers are discontinuous, and you may need certain technologies to look for water here. Then there is sandstone. I have a picture from Vietnam here. Often sandstone has a general porosity, so it is kind of a continuous aquifer, but it often has much, much higher yield in fracture zones. You see a fracture zone here, and you can see it's basically between the two gentlemen on the photo. So it's like 3 meters wide. If you hit that, you get a much higher yield than if you drill in between. And then sandstones may be interbedded with shale and siltstone, mudstone with a low yield. So this is a more tricky one to find water into. And I will now show the only more technical slide I have is a siting strategy for 2D resistivity geophysical profiling in such a layered formation mixed of mixed sandstone and shale and refractures. I hope you can see my cursor here, because I'm showing some potential aquifers. These can be the sandstone layers, and as you see, they are dipping here, and in between it could be shale or mudstone. So what I'm showing here is there's like 2 interesting dipping sandstone layers, and if you drill in them, here are the black boreholes showing you will hit the sandstone like that. So, but in this sandstone, you can have fractures zones like what I showed on the previous slide. So actually, to find an ideal drilling spot, we would normally first do a resistivity profile across the layers, which is called the strike direction, so perpendicular to strike, find the sandstone layers, maybe a second one to confirm, and then do a third profile to, in the sandstone layer, find a fracture zone. It has to be in the sandstone, because if you find it in the siltstone layer or mudstone, you will not get water. So this is a way your geology determines your investigation strategy. Fast forward to limestone. This is a picture from Denmark. Limestone may have a porosity like it has here and be a continuous aquifer with a high yield. It can also be a discontinuous aquifer. This is, I think, an amazing picture from Perak in Malaysia, where you can see actually a small house built into a fracture or solution cavity in limestone. So limestone can be very inhomogeneous and discontinuous with very high yields possible in solution cavities and fractures. Basalt may or may not be continuous aquifers. Here's a picture of basalt from Vietnam, where you note fractures, but you also note a general porosity. So basalt is very varied, may have high or low yield. Crystalline rock like granite only has water and fractures, and that means it's a discontinuous aquifer. Here is a picture of gneiss, which is a crystalline rock looking a bit like granite from Ghana and West Africa. And you can see the wet zones colored black on the profile. That's in fracture zones. So unless you hit the fracture zones, you're not going to get any water. And in crystalline rock, you'll generally get a low yield anyway. And you have to profile perpendicular to your fractures to find your water. So now I'm trying to describe a little bit the different investigation strategies. And first I give like the full package here. If you want to map a large area and find as much water as possible, and you will see I have shown in black, these are the activities that are always carried out. In blue, that's the activities that may be omitted by authorities because they would rarely go to the level of actually identifying well fields. They would leave that for the regional authorities or typically the water supply companies. And then with the red asterisks, I have mentioned things that I will give a few more details about later. So any investigation should start with collection of existing information and desk study. And then the next point, airborne geophysical survey. If you really want to map a large area, we see no other way than doing an airborne geophysical survey to get the overview and combine that with existing geological maps. Then typically, if it is a regional water supply company, they would do ground geophysics to site their wells in order to pinpoint the exact drilling points. Now, state and national authorities may omit that if it's a more general water resources mapping, but they would also typically do exploratory drilling, test pumping, water quality analysis. Sorry, I just wanted to do this and then go up here again. Then estimation of maximum sustainable groundwater abstraction is a very important issue to ensure sustainability. National authorities, state authorities may not do that, but regional water supply companies have to do it. Everybody has to do assessment of groundwater quality. And then again, we see typically national authorities may stop at locating potential abstraction areas, whereas water supply companies have to go down to do well fields and infrastructure concept plan where they, for example, identify points where the treatment plant should be and where connection to the distribution system should be. Also, environmental impact assessment is important to do detailed assessment of specific well fields. And NIRAS, our company, always advocate a risk analysis because there are risks in these kinds of projects. And we do typically systematic risk analysis. And then the rest of it is more straightforward, detailed wellfield design, wellfield construction, pumping strategy, and monitoring program. So now I will give a few more details about the items with an asterisk here. First, airborne geophysical survey. Here is a picture from a Danish company, one of the world market leaders. You see a helicopter carrying a big coil, which sends a magnetic field down into the ground. And by doing that, they can measure some return eddy currents and map the distribution resistivity, which in turn can be used to identify aquifers. When you combine with drilling results and geological maps, resistivity alone does not tell exactly where water is, but where you could look for it. And they can do up to 400 or 500 line kilometers, as we call them, per day. So this is the only way to really cover a big area fast. This is the ground geophysical kind of study, 2D resistivity profiling, here done by OCNED in Malaysia, and that we almost always do to pinpoint drilling points, but not really always. I'll get back to that later. When it comes to estimating maximum abstraction, here is a cross section where you can see the aquifer itself is this dark orange here, and the light orange is called impervious strata. That could be granite, for example. And of course, groundwater comes from the rain. You see the infiltration here, and naturally it would flow to the ocean. You can never ever abstract more than your infiltration. Then you are mining your groundwater, and it will not be sustainable. But there can be various other things limiting your abstraction. For example, you should not reduce your flow in your rivers too much, and you risk saltwater intrusion as shown here below if you pump too much. So estimating the sustainable maximum abstraction is very important. And for bigger abstractions, we generally always use computer flow models. Here is a flow model from Denmark, where we are modeling the cone of depression when pumping. And I have compared here, the flow model showed a drawdown in this particular well of 0.25 meters, and simple Excel calculations showed 0.31. So sometimes we do only the simple calculations if it's a smaller abstraction without huge environmental impacts. Environmental impact assessment, here is a figure. It's a little bit tricky, I have to admit, but the recharge is here and sustainable abstraction is here. And of course, the line where the recharge equals the sustainable abstraction is the absolute maximum we can get. But then a lower abstraction is often the case, and that is expressed in the sustainability factor, which is 1 when we abstract the full groundwater recharge, but less when we look at various environmental impacts. I will not mention all of them here. I will mention only 2. Base flow, which is the flow in rivers. These are these orange triangles here. And as you will see, when you have to consider base flow, typically by comparing with your the legend here, you can only abstract between 15 and 70% of your recharge. The other one is saltwater intrusion here, where you can typically abstract somewhere between, say, 30 and 80% of your recharge. Otherwise, or even down to 15. Otherwise, you get saltwater intrusion. Now I switch to a different kind of goal, and typically a different kind of project owner. If it's a local area where you want to find as much as possible groundwater, this is the same list of activities, but I have colored in red what I propose that you should not do, and that is the airborne geophysical survey. If you look at a certain, for example, an area around a water supply treatment plant, you would omit the aerial survey, but you would do all the rest as per this list. Moving on to if you are in a local area and you want to find a defined yield, but this yield is actually still high compared to the potential yield and gives also a potential environmental impact, I also think you would have to go through the whole list except for airborne geophysical survey. Moving on, if you have a low yield compared to potential yield, but you have one of the discontinuous aquifers like granite, for example, you would, of course, again omit airborne geophysical survey, but you would still do your ground geophysics and exploratory drilling and so on. The blue one here is a light version, because if you have a low yield, you may do a light version of estimating your maximum sustainable groundwater abstraction. And you may basically more or less skip all these more technical environmental impact risk analysis, so on, go straight to wellfield construction, preparation of pumping strategy and monitoring program. I'm not saying it's like this all the time, but this is a typical situation if you are in a local area and you want to find a defined yield. Now, if you're in the same situation, but basically you have a continuous aquifer, then you may also omit your ground geophysics. That means you can drill anywhere. If you have widespread alluvium, you can drill anywhere. And if it's a low yield you're looking for, you would go straight into drilling typically. Finally, if you may be looking for a low yield, but actually you have a high water quality requirement, and you need to make sure your groundwater is not contaminated, then I would argue you still need to do your ground geophysics. So that has again been colored black here. And you need to do more detailed location of well fields and risk analysis. The reason you want to do this is you want to map the vulnerability or protection of the aquifers, whether they are covered by clay layers that can limit contamination. So to stick with time schedule, I go fast forward to the conclusion here. My conclusion is that your goal and your geology basically determines your investigation strategy. The overall strategy, but also detailed layout of geophysical measurements and so on. So I hope you were not blown away by this very fast presentation, and thank you very much for listening. I think questions here, Denise may help us. I think questions come at the end, or are they coming continuously, Denise?
You will answer the questions at the end of the presentation.
Okay, so I will stop for here, but I will just briefly introduce my colleague, viewer Chris Blem, who is, well, he has 1 year less experience than me. So he has 34 years, I have 35, and he worked in 15 countries. He has a background in engineering, but also specialized in hydrogeology. And he has also worked a few years in Malaysia. He will take you through groundwater policies in Denmark. So over to you, Chris, and thank you, ladies and gentlemen.
Thank you, Michael. Chris, maybe just before you start, perhaps we want to do the survey now.
Yes, can everybody hear me?
Yeah, Handy, maybe you can pull up the survey questions. So we will have our attendees to answer these 3 short questions. Is that enough? Enough time? Okay. Chris?
Okay.
Here's our result. So
thank you very much for
100% agree.
Inviting me to this seminar, interesting seminar. And I hope you can see my presentation now.
Yes.
Go from, and I'm going to inform you, talk a little about Denmark's policy on groundwater. And my agenda is presentation. I will probably skip that because Mikael already introduced me. For that, I will give some background information about the situation in Denmark and our policy on groundwater and water supply, our legislation on our national plans for groundwater mapping and action plans. And I'll inform you a little about our detailed surveys. And then I will also, this is quite new, we have something we call documented drinking water safety. And that has been introduced in the last 5-8 years. And then I also will inform you a little about more general environmental safeguards, measures and regulations we have here in Denmark. And at the end, I will come with some challenges that the water supply in Denmark is facing. Yeah, as I said, I'm 34 years. I'm an engineer and been working both Denmark and abroad, and also a shorter period in Malaysia. If we go to the background for Denmark, the population is about 5.6 million. So it's quite a small country here in the northern part of Europe. We have where our neighbor is Germany at the south. Our annual extraction of groundwater is about 400 million cubic meter. That's for the drinking water purpose. And it's been decreasing for the last many years. And I think the last 20 years, it has decreased about 20%. But probably for the last 40, 50 years, it has been decreased. And as mentioned before, 100% of our groundwater, our drinking water is based on groundwater. And we also rely on simple treatment, and no chlorine is added to the water when it's distributed to the consumers. Our waterworks are 100% public owned. So it means there's no private companies owning the waterworks that can make profit or whatever. And 35% is actually what we call cooperatives. I mean, the consumer owns the waterworks, and that's mainly in smaller villages, city, towns, and so on. And the non-revenue water rate in Denmark is as low as 4 to 5%. So that's quite good. As I said, we have many local waterworks, about 2,200. And then we have about, of them, 100, 150 is larger utilities owned by municipalities and so on. And the rest is those cooperative waterworks, as I said. We have about 10,000 production wells, and Denmark is agriculture country, so our agriculture covers about 60% of the total area of Denmark, and the cities, the infrastructures, and so on, roads and etc. that covers about 10%, and the remaining is forest and nature and so on. So that's more some of the background here in Denmark. Yeah, and I just put this one. Mikael also mentioned about this recharge and utilization, and the challenge in Denmark is that in Zealand, where it's brown or red, is where we have the capital, and it's very high dense population. So actually the abstraction has been higher than the sustainable recharge, and also the recharge in this area is lower than in the western part, where the recharge is considerably higher and the demand is lower. So that has been a challenge for a long time here, especially around the capital, Copenhagen. The policy, it says, I mean, that's a political decision, political demand, that drinking water in Denmark, that should be based on unpolluted groundwater and only simplified treatment. So no advanced treatment with membrane filtration or something like that. And it's also another one is that the polluter should pay for cleaning up. I mean, for those sites that get contaminated and so on, the polluter should pay for cleaning up in order to secure the quality of the groundwater for the future. And then, as I also mentioned, we should follow this new procedures or safety, drinking water safety, and it's more like water is now treated as a normal food production. I mean, it's the same as you produce meat or anything else you sell in the store. We need to follow the same procedures, and that's quite new in the last 5-8 years. And I said before the treatment should be simple. So in general, we only try to remove the volatile gases by aeration, and then at the same time we oxidize the groundwater, and then we can remove the iron and manganese by sand filtration. And that has been more or less the traditional water treatment for many years. Lately here now in the last also few years, 5-8 years, we have started to also to soften the water in order to reduce the hardness, especially in some areas where we abstract from limestone, the hardness is quite high. And that means you lime will precipitate on in the network and installations and so on, and that is quite costly. So that's an ongoing process now in some of those bigger water treatments. They are installing water softening. And we don't add any chloration or any post treatment to the water when we deliver it out into the distribution network. And it is also pumped directly to the distribution network in general. Also, as when we have some regulation for water supply permission, and that is to regulate the water body. So it needs to be sustainable, and it's also for the environmental protected areas. I mean, we are not allowed to abstract water and to dry out the wetlands and streams and so on. So there's a lot of regulations, and it's also to ensure that we still have a very high quality of groundwater, and it should also be feasible, economic feasible for the abstraction. And at the end, there's also quite a few regulations for designing and first siting the boreholes. I mean, you need to be not too close to, for example, sewage lines and so on. There's some very demands how close you can site the well. And of course, the design and maintenance is also very important. It should be sealed and the borehole, so there's no risk for contaminating the aquifer. And you need to have, I think there's a 25 meter around the boreholes where it's we're not allowed, a protected area where not allowed to do anything. So that's the regulations. As Mikael also mentioned, we have done mapping in Denmark for many years, and before it used to be, I mean, on a regional level or maybe a local level. But about 20 years ago, there came this more national mapping plan, and that was in order to still maintain the policy that we can rely on unpolluted groundwater and only with simple treatment. So then we started this big program of mapping the whole country about 20 years ago. It was meant to finish in 10 years, but then it was, I think, extended 5 years, and now it's extended another time. So now the plan is to finish all this mapping at the end of this year, actually, after 20 years. And it was also in the beginning, it was focused on those aquifers with very special, very good aquifers with very good quality, and also catchment areas for water supply systems. And it was done under the Ministry of Environmental, all this work. And it's also similar to what Mikael said before. I mean, you start with collecting and analyzing existing data, information. You go out and do some detailed surveys, geophysics, drill boreholes, pumping test, water quality, and etc. And then you go out and also map the land use and threats from hotspots, contaminated sites, in order to do a risk analysis. And then you try to map and delineate those vulnerable areas related to the aquifers. And all this mapping should be based, outcome should be preparation of action plans or monitoring plans in order to secure the quality in the future. Because if there's a risk, it's not enough just to map. You also need to do something, and that's where the action plan is required. We have all in Denmark. We have a lot of available data, and maybe if I try to see if I can click to this, open this link here. I hope it works. Let's see. No. Well, I mean, we have a lot of data stored in national databases. So all those mapping you can find on in databases. Those areas with special drinking interest and so on. No, it doesn't work. And this picture here at the right, well, it was more or less the same I was going to show you online. But this shows all the boreholes and wells drilled in Denmark, not in Denmark, but in close to Copenhagen. And since I think it has been some law that nearly for 100 years, every time you drill a borehole, you need to send a report to the Danish Geological Survey. So, and you can find all those data online. You can find what is the purpose of the well. Is it for drinking water? How deep is it? When was it drilled? What is the geological layer? And where have you put the screen? So everything that you can find online. Okay. As I said before, all this mapping was led to action plans, and it does actually be the municipality who is responsible to prepare those action plans. But of course, it should be in close cooperation with the stakeholders. So they need to be involved, and that's of course the utilities, waterworks, the farmers, the industry, and NGOs, and so on. And those action plans should try to keep it simple, but it should be very informing you where the action is needed and what is needed, and it also maybe is setting up a monitoring program to follow the development, see if the action plans is actually helping, or you need to modify the action plans after some time, and who is responsible. And it's also, of course, important to provide information why those action plans and protection is needed. And finally, you need to make a time schedule and for the implementation of the action plan. And I have here some examples. I mean, it depends on the area what's needed, right? But it could be, sometimes it's maybe just information and campaign about reducing the amount of pesticides. Besides the farmers, many households have used a lot of pesticides in the gardens and so on, and that's have tried to reduce that amount considerable, because it's actually a risk for the groundwater. It has been closing old boreholes. Many boreholes has been out out there and open, so it was really a risk that surface water could run into the aquifer directly. So it has been sealed and closed. And it's a remediation and cleaning up of hotspots around in the catchment or in those aquifers. And it could be also use less fertilizer or pesticides close to the wells and in those vulnerable areas. And that is normally for the farmers. And if they should use less, they will of course want to have some compensation instead, because then the profit will go down. So they need to have some compensation. It could also be changing the pumping strategy, and it could at the end it could be saying, okay, this well field is not sustainable for in the future, so you need to look for a new well field. That was just some examples of action plans. As I mentioned before, this documented drinking water safety has been introduced, and that has also, one of the conclusion, or one of the what's happening is that now when they install and build new water treatment plants, they will be very closed and sealed with using stainless steel tanks and pipes and so on, and fully automized. And not only that, but they also now building new waterworks with what called different lines, maybe 4 or 5 treatment lines that's totally separate. So one treatment line will probably get water from 1 or 2 wells and treat those the raw water from those wells and pump it out. And if something happens in the wells, get contaminated and so on, you can close that production line down, but the other 2, 4, 5 production lines can still continue and deliver clean and safe water. So that has been one of the consequences of introducing this one, regulations. And this is just another example. This is a well site out in the field. And I also mentioned before that we have started now to soften the water, the drinking water, because that's just economic, analysis. It's very expensive if you need to change the network because of all this precipitation of lime and the washing machine and so on that will only last for a couple of years. So now we have introduced this process. That has been done in the Netherlands and Sweden and so on for many years, but it's quite new in Denmark. And that's different processes to do it. I mean, the one we are involved in is called the pellets process, and it's basically the water comes in here, and then you have sand, and then it's a fluid bed column. And then you regulate the pH of the water by adding natrium hydroxide, and then as a base, and then the lime will precipitate on the sand particles, and when they get more and more lime on it, they will be heavier and they will fall to the bottom, and then you remove it and can use it actually for fertilizer. And then you get a more soft water. But that's, as I said, that's different. It's a different process you can use. Safeguards. In Denmark, we have an Environmental Protection Act, and that says that we should protect the environment in order to ensure sustainable development, and that's related to humankind, and related to animals, to plants, and everything, all the surrounding animals. And it should also prevent, or at least reduce, the pollution of the water and air and so on. It should also promote implementation of new clean technology, and it should promote recycling of waste materials. And the last one is actually very hot at the moment in Denmark. The government has just introduced a new regulations for recycling waste. You need to sort your waste in 10 fractions. That's at least that's a plan. As I said in the beginning, Denmark is an agriculture country. So there's also some safeguards there and restrictions to the farmers, and we have a lot of animal production in Denmark. So in order to have those animals, you need to have some land where you can spread the manure from the animals. And you say one animal unit per 1 hectare. 1 hectare is 10,000 square meter. One animal unit is that's a cow or cattle, and that's related to 4.3 pigs. So I mean, so if you have 100 cattle, you need to have 100 hectare of land to to spread your manure. And then we have very restrictive regulation to use of pesticides and introduction of new pesticides. And then in Denmark, we have normally in the old days, the farmers, they plant there during in the spring, and then they harvest in late summer and plow, and then the field was brown for the rest of the winter, 6 months or something. But now they are obliged to plant new crops and so on just after they have harvested, in order to have green fields during winter, in order to reduce the leachage of nutrients, nitrogen. So that's the regulation we have put in Denmark, right? And then we have a lot of, as I said, a lot of contaminated sites in Denmark. And I think that last number I heard was about 12,000 sites, lands that had been registered in Denmark. And in the beginning, I said that the polluters should pay for cleaning up those sites. But we have also some very old, big hotspots that actually was started before any legislation was in place. So, I mean, so legally you cannot come after anybody. So then this is authority to finance those cleaning up and remediation of old hotspots. Yeah, finally, I will just tell you a little about the challenges the Danish water sector is facing. I mean, there's been some demand requirement that the water supply, the waterworks should increase the efficiency. I mean, the water is monopolized. I mean, if you have one hooked up to one waterwork, you need to buy the water from that specific water work utility. You cannot say, no, I go to the neighbor and buy water. So, and that's why they have put some requirements, demands to increase the efficiency. And that's in order to reduce the energy consumption and to also to reduce the impact on the environment and the climate and so on. And I think since the last 10 years, the efficiency has been about 15%, but they still believe that they could increase efficiency about 20% the next 10 years. And each larger water utility, they will have some, they will get some demands, requirements, or what to call it, goals that they need to achieve benchmarking. And then Denmark is a member of the European Union, and they have water frame directives and so on we need to follow. And that has also been a challenge, but I mean, I think we are good on the way. And then there comes always discover new pollutant threats, mainly probably from the agriculture, the pesticides. And every time you get more and more clever, you can discover and detect more compounds. And then when you start to measure and analyze for it, you'll probably find it. So every 3 or 5 years, there comes a new debate about new pollutants that you suddenly find in your groundwater. So that's a challenge. We have some climate change also in Denmark. It's raining more. Actually, it could also be a good thing, because then the groundwater recharge will increase. But it could also be sea level rise in the sea level. Many cities in Denmark is very close to the sea, so we have faced seawater intrusion in several well fields. And that at the end, we have also some structural changes in the sector. In the beginning, I mentioned that there was a lot of small waterworks, and with all your new requirements, demands, and so on, it's very difficult for them to fulfill that. And normally, that has been driven based on voluntary people. I mean, retired blacksmith or something like that was running the small waterwork, but that's very difficult now with all those requirements and challenges they are facing now. So it seems that they are merging to bigger utilities. Yeah. Okay. I think that was what I would like to present for you this afternoon. So thank you from my side.
Thank you so much, Chris. So now maybe I should invite Dennis to review the questions. It's now Q&A. Dennis? Dennis, I think you're... Okay. Can you hear me now, Dennis?
Yes, I can hear you.
Okay, so we have a lot of questions. I can see 18 of them. Perhaps you can go through the question now, and then you can let us know who should answer the question.
Okay, do you have the number of the question, or do I just go through this one, right?
Can you see the icon Q&A at the bottom of the screen?
Yeah. So I see the first question here. They said, do we need license or approval from respective states, government, to and use groundwater on our own premises or land? To answer this question, yes, you need, especially in Johor, Selangor, and few other states, that you need to apply a license and approval, and then you have to pay a certain royalty. For example, in Selangor, you need to pay 3 cents per meter cube of groundwater utilizations to a department called LUAS. LUAS is Lembaga Urus Air Selangor. That's for Selangor. There are other states, you have their own names for this department. Okay, yes. And the second question here, wait.
Dennis, I think you need to on your video.
Where's my video? Okay.
There
Can you see me?
Yes.
Can you see?
Yes.
Okay, I think I answered the first question. Okay. So the second question is, how to develop water resources in urban area? I think this one maybe Mikael or Chris can answer this question.
I think I can do that. Yes.
Okay.
Of course, in urban areas, there are at least 2 and sometimes 3 things to consider. One is contamination. If we have a vulnerable aquifer where contamination may reach the aquifer, then that is definitely something to consider. And as Chris explained, in Denmark, we try to omit advanced treatment like active carbon filtration, for example. So if we have urban contamination, can be, for example, from industries, it can be petroleum or oil, or it could be solvents, for example. I mean, like dry cleaning shops, they have been using solvents at least earlier and often wasted them. So contamination has to be considered. And sometimes, basically, we end up giving up and not using groundwater in urban areas because it's too difficult, too contaminated. The second issue I can think of is practical. You may find it more difficult to find areas to drill and have your pipelines and all that. All the logistics of it can be more complicated. And then in certain areas, but not all, there can be an issue of ground settlements. I know that in Malaysia, this is hugely exaggerated. I mean, ground settlements are actually quite rare. But if we have thick peat layers or thick soft clay layers where we lower the groundwater table, we can locally get settlements. In Malaysia, people seem to think it's a bigger problem than it actually is. But these are the main things to consider in urban areas. And as I said, sometimes if you have alternatives, you decide to go outside the urban areas and do your well fields outside the cities.
Okay, good. So the next one is, how do you control agriculture pollution since your aquifers are in glaciers still? I mean, this is referring to Denmark, I think.
Yeah, I think I also touched it when I gave the presentation. As I said, I mean, first of all, we have those safeguard measures that we need to have green fields also during winter to reduce the leakage from the nutrient. We try to regulate the what I call it the households, the animal production, in order not to put too much manure and thereby also too much nutrient on the field that will wash out and could risk the groundwater. And finally, we have also done that mapping there where those vulnerable areas, saying that, okay, we need to do an action plan where we actually reduce the pollution from the agriculture. I mean, nitrate and special nitrate. But that will probably always come with a compensation, because I mean the farmers they will always argue then they lose revenue, so then they need to have some compensation. But so that's different measures. But in some areas there's no problem. So, but it always depends on the aquifers. Okay. How vulnerable they are.
Maybe the next two questions also referring to you, I think, Chris, maybe you can answer. Where manganese concentrations are high, what are the methods that you use for oxidations? And what is the Denmark drinking water standards if you simplify water treatment process? Thank you.
Yeah, I mean, for manganese, as I said, we normally just had this, what I call it, quite simple treatment with sand filtration, where we remove manganese and iron. And normally, I think the iron is probably up to 4 or 5 milligram per liter we can remove with this quite simple treatment, and otherwise, and manganese is less, probably maybe half to 1 milligram. And I think that's more or less cover everything. And if you have higher, I think you will probably not use that water. That has been so far. And what is pH associated? I mean, if you do a normal aeration, I mean, that's normally we don't pH regulate it. But as I also mentioned, when we soften the water and so on, you need to pH regulate the method. But that's, I mean, this is a little more for a chemical specialist than me. What do you say? What is a drinking water standard?
Yes.
Yeah, that's how can we ensure it's to consume, and that's also where I said where we have introduced those drinking water safety procedures, and we go out and we take a lot of measurements and water samples out in the network to ensure that the quality is good, and that mainly when you're out in the network, it's biological what call water samples and analysis you do. And but that, I mean, that has also been a decision we try to avoid to chlorinate the drinking water, because you can taste it, right? So people don't like it. But you have, if something happens, then it's a big effort to try to get rid of it again. So, but it's.
Can I supplement here?
Yeah.
I think it is important to note that almost all groundwater has no bacteriological contamination. It is only very, very shallow water. Unless there is a construction error in your water well, where you get surface water into the well, there will not be bacteriological contamination generally in groundwater. So that's unlike surface water, where you need to kill bacteria. So the source basically in almost all cases is uncontaminated. So it basically, the rest depends on the hygiene in the system, that everything is clean throughout. And secondly, to maintain always pressure in the system. As long as you have a pressurized pipe, bacteria do not enter the pipe. And in my house here where I'm sitting now, I've lived here for more than 26 years. And I think we have lost pressure maybe 2 or 3 times in these 26 years. So by always maintaining positive pressure and good hygiene and having an uncontaminated source, Danish drinking water is generally bacteriologically safe, and everybody drinks water straight from the tap. It's even served in restaurants straight from the tap as well, and safe.
Okay, good. Then next to answer the Muhammad Yudi Haryadi questions, talking about there's a lot of rice field in the area. So the groundwater contain high iron and manganese, I think. So how can we simply reduce both? I think the simpler method and cheapest method is by aerations, oxidations, and filtration. This is what Denmark is doing. A very, very simple filtration system, no complicated system, straightforward. If you have seen the process, is very, very marvelous, straightforward. Okay, then to answer Steve Morton question, what would you say is the most important first step to increase groundwater development sustainably in Malaysia, either through governments or the water industry? I think I answer these questions simply because this is state government and the federal governments have to work together, because water is a state matter in Malaysia, but the funding may have to be shared from the federal governments or the state government side. Both have to put in hand together and develop this vast resources that we can depend on, because as you know, we only use less than 3% of these resources. Okay, then do we have a groundwater map for Peninsula and East Malaysia? To answer Mr. KK Louis questions, actually, we have hydrogeological map of Malaysia and East Malaysia, not so much on the groundwater map. Hydrogeological map telling you what kind of formations you are expected, most likely to be encountered, and what kind of yield that you can expect in that particular areas. Yes, we have this kind of hydrogeological map in Malaysia, developed by the Geoscience Department. Okay, then the other one in Denmark, I think Michael and Chris, you can take this question. In Denmark, how is your government deal with illegal groundwater use and pollutant that come out from it? In Malaysia, I don't think we have a law in government. Yes, we have a law in government on this, but then in Denmark side, maybe Michael and Chris, do you want to take this question?
Well, I mean, yes, everybody needs to have permission to extract groundwater, even for private use or irrigation and so on. And I think everybody is following. I haven't heard of a lot of illegal use, and the pollutant that comes out from it, I don't really know what means about that, because of course, if you drill it not properly, you can pollute the aquifer. But normally, I mean, you don't pump the groundwater back to the aquifer. So I don't know. But in Denmark, it's not really an issue of illegal use of groundwater or connections or whatever. And everything, I mean, you are not allowed to touch even the water tap back in your home. I mean, it needs to be authorized people who's doing that. So, and I think more or less everybody's following that. The threat is more from contaminated sites and so on. That's where you have the problem of polluting the aquifers. Have you anything to add, Michael?
No, I think it's right what you are saying, and I think everybody should know Denmark is a country where people typically follow the law, and you can just watch the traffic in Denmark compared to the traffic in Malaysia. A huge difference, and that is the same when it comes to other aspects of life and like groundwater regulation. Generally, there's a high tendency to follow rules and regulation in Denmark.
Even pay tax, right? I mean, yeah.
Even pay tax, yes.
Okay, the next one is about talking about North India. Mike, maybe you guys can take these 2 or 3 questions straight away.
Yeah, I mean, in Denmark, you need an abstraction permit, and this is being monitored. Of course, nothing is perfect, but again, there is a tendency to follow what you actually have been granted as abstraction permit. And the authorities, the municipalities, they evaluate the size of your abstraction, and if they think it may be critical, they typically request you to do a groundwater model, which, as if you were a farmer, you would need, of course, a consultant to do that for you, or a full environmental impact assessment. So again, with this system of a very well-established groundwater legislation and general law enforcement, this is rarely a problem in Denmark. As Chris told you, there are areas in Denmark where we have overexploited aquifers, but that is mainly earlier, and now it is gradually being managed by moving the water abstraction further away from the main cities to avoid that problem. So I'm sure India, I mean, talking about law enforcement, India is probably as much on the other side of Malaysia as Denmark is on the law enforcement side. So, of course, in India, there may be huge problems with that.
Okay, the next one is they want to know, Mr. Lee want to know how Denmark handle the water without chlorinations.
I think we answered that question just before, didn't we? I mean, yeah.
Yeah.
Because we, as also Mikael said, I mean, the water resource is based on uncontaminated water, and then through the whole process, and now when you need to also have more or less closed process, and risk is very, very low, and then you have a very intense monitoring program to ensure that the water is following the standard.
Because Denmark, you can drink the water from a tap direct, you know. Because
we have always done that.
That's the reason why no chlorinations is allowed.
Yeah, I mean, chlorination doesn't taste good. It's better if you can avoid it.
Yeah, yes, that's right. Yeah. Okay. The next one is also referring to Malaysia and Denmark. What would Denmark historical experience and advice on the approaching of institutional and economical limitations on this groundwater? You see the question?
Yeah.
I think it is a very cultural question. I mean, because as I said, in Denmark, generally, there is a high degree of law enforcement. And then combined with that, we have developed groundwater legislation and regulation over the last more than 100 years. As Chris explained, more than 100 years back, it became a requirement by law to report your wells, for example. So I think it is something that takes time, and it would also do that in Malaysia.
I still believe that everybody thinks it's still a good idea to rely on unpolluted groundwater as a resource, right? Because, I mean, the technology is there. I mean, you can use, I mean, in France, they pump water from the Seine with what called nanofiltration and whatever, right? It's more expensive, but also hygienic and so on. People want to have drinking water based on a safe and clean resource. So, and we are also willing to pay for that.
Okay. The next, how is a yield study being conducted? Does it being conducted through the year-long in frequency? This is to ensure there is sufficient yield during drought season. Maybe you guys can answer this question.
Yeah, I mean, when we do our groundwater modeling, we do model typically for more complicated situations. We may model what happens in the dry season. Denmark does not have as dry a season as in Malaysia, but on the other hand, there's typically around half a year, which is the Danish summer, with very little groundwater recharge. So we try to model what happens in the dry season. And in order to do that, typically we do use groundwater monitoring data so we can see the seasonal variation. And this is also what we do in projects like in Malaysia and other countries, that we monitor the groundwater throughout a full calendar year, so we can see how much does the groundwater level go down in the dry season. You know, sometimes we have to move faster and model it, and then do the final adjustments in the production stage, where we have to monitor the groundwater table and, if required, adjust the abstraction so we are not drying up the aquifers in the dry season.
Okay, the next one is interesting, Michael. Maybe you can answer this. What is the view? What is your view on the use of tube well versus horizontal collector wells?
To me, I mean, tube wells are generally cheaper and a simpler technology and more well-established.
And more sustainable, I think, to add in, I think it's more sustainable definitely compared to the radial, because radial well is shallower.
Yeah. I mean, but on the other hand, there are situations where radial collector wells are required if you really want to utilize a resource, and that is the main situation. Is or you can say there are two. If you have a very thin aquifer, it may not be really possible to abstract through vertical wells, and then you may want to move into radial collector wells. And the other one can be well, a combination of that possibly, and then riverbank infiltration. If you want to abstract river water through a layer or a zone of sand, radial collector wells may be required. But I believe radial collector wells, being a more complicated and more expensive technology, should only be used when required, and when possible, it's cheaper and easier to construct and easier to maintain vertical wells.
Okay, the next one is what are some example of NIRAS earlier, because he's talking about this will produce the scheduled waste because they use coagulants and extra. But then I think in Denmark condition, there's no chemicals process is allowed. Therefore, there is no scheduled waste produced from this method, you know, from this treatment process. To answer this gentleman question, because if there's no chemical being used, so therefore there will not be any scheduled waste used. Okay.
Yeah.
How is impact of seawater intrusions in Denmark, and how do you deal with it, gentlemen?
Well, that historical, that has been a challenge because, as I also mentioned, most of the cities are close to the sea, and you don't want to have your well fields close to the town cities, and so it has been sea intrusion in quite a few well fields around, especially around the Zealand, in Copenhagen, and but we have sometimes closed it and moved it away, and also reduced the pumping to get a more sustainable abstraction. And I think, as I said, the annual abstraction was decreased 20% the last 20 years, but I think it's nearly half. If you go 40 years back, I think the abstraction is nearly only half of what it used to be in the 70s. So that's also helped the problem, right? But of course, it has been quite a big problem in Denmark before. So, and we are very aware of it and monitor it, and set up those groundwater modeling, and to ensure that we have a sustainable abstraction from those wells, especially those close to the sea. Yeah.
Okay, good. To Mr. David, there's one question from David talking about asking Birger possible on the system and solutions to remove iron and manganese from the groundwater. I think this one we can communicate after the webinar. We can discuss on some kind of processes later.
Okay, yeah.
Okay. Then the next one is, do you acquire the land for the locations of production well? If so, how? And what is the minimum area of the land for production well?
I think I can answer that one.
Okay.
Because it's quite different. In some cases, the water supply company does acquire the land, and typically that would be as a minimum 20 times 20 meters. But there is, with new legislation, there is a 25-meter zone from the water supply wells where no pesticides are allowed in fertilizer. So, so even if you acquire 20 times 20 meters, you have to have a deal with the landowners not to use fertilizers and pesticides closer to the well than 25 meters. In other cases, we have the wells located on private land, and then there is a registration in the public register that there is a well here, and the landowner has accepted that well, and he gets a compensation for it, but it is still his land. So we have both models here, where we acquire the land and where we don't do it. But of course, in any case, the landowner has to agree, and he will get compensation even if he still owns the land.
But it's also in the public interest to have those well fields. So I mean, if the landowner doesn't agree, we have some law and regulation that we could go in and force and actually drill the borehole and the wells, right? But of course, normally it's very rarely. I don't think that ever happens. So it's normally on basis of negotiation and so on. So, but if it's needed, we have also regulation and law in place that we can cite the wells. Yeah.
Okay, the next one is the same gentleman. He was asking. It was mentioned that after the basic treatment, water is distributed direct to the consumer. Where is the treatment plant located? Is it just adjacent to the production? I think I can answer this question, gentlemen. The treatment plant is at the well field, because we are creating a well field. The treatment plant is located at the well field. So it's at the point of needs. I think this is a very simple way. That's why I always amaze how Denmark is doing, and resulting to their 2,000 over water operators in a small country, whereby they're producing fantastic, good quality of drinking water. Okay, Mr. Ng, again, what's the best approach? This is also, Mr. Ng, we can discuss with you after this webinar. We can give you the detail on how to get rid of your pollutants if you have facing this issue. The other one is, since you didn't use chlorine, don't this problem of contaminations of your water, how to ensure it? Maybe, gentlemen, you will answer this in Denmark context.
Yeah, but I think we already answered, right? I mean,
yes.
So we based on unpolluted groundwater, and we have a quite
no
intense monitoring program to ensure that it's still clean. Yeah. Okay.
The next questions I think I can answer. Actually, there's no overlapping. This gentleman is asking whether there's overlapping on many ministries in Malaysia and as compared to Denmark. Actually, groundwater is always a state matter. Is always referred to the state's authorities. So this shouldn't be any confusions.
No, and I think it's the same in Denmark. I mean, I don't.
Yeah.
I mean, it's very the role. It's very clear who takes care of what.
Yes, it's very clear.
Yeah.
There's no overlapping.
Yeah.
Okay. Then here, how do you address the high level of calcium in the water? Yeah, this one maybe. How do you answer?
Well, that's what I think I just touched about this softening the water, right? I mean, because that has been
softener.
I mean, for many years we didn't do anything, and then all this lime was precipitating in the network and installations and so on. And it's, I mean, so in some places you could change your washing machine after 2 years because it was clogged, and so now it has started, right? So that's how we're addressing it. But it's only in some areas in Denmark. It's not everywhere. Yeah.
The next one, he said, Mr. Mikael Tong is asking, if the source of the water is exhausted, what happened? Would it cause collapse or sunken hole?
Mikael, that's yours.
Okay, yeah. I mean, it may happen, but very rarely. I mean, normally, if we exhaust the groundwater resource, the aquifer, the water table will go down, and eventually we are mining the water, so we cannot continue pumping because the water level is falling. Now, in some special cases, this can end up with a collapse or a sunken hole, but that is maybe 1 out of 1,000 situations where this could happen. And that is mainly if you have soft clay, peat, or sometimes karstic limestone, where lowering of the groundwater table could result in a sinkhole. Or if you have a well which is not correctly constructed, so it does pump in the sand, then you may get a settlement of the ground. But that is then because your filter, your screen in your well is not correctly designed. So it's a very rare situation.
Besides that, Michael, sorry to cut in. Besides that, we have to make sure the well, the deemed production well, has to be sustainable, because we must make sure the recharge is more than the discharge. Therefore, the exhausted words shouldn't come in if you create a well field.
Correct, Dennis. Yes, if it is correctly done, this will not happen. But if it does happen,
this cannot happen. For a production well field, this cannot happen. Okay, and then this one to ensure we get consistency and reliable groundwater quality and quantity before we construct the water treatment plant. How long do we need to monitor both parameters? Gentlemen, this questions from Muhammad Fauzi Omar.
Yeah, I'm normally, as we said and Mikael said, we start with those mapping and investigation, and also pumping test, and taking water samples and so on to find out the water quality. And then you do some risk assessment, you do some modeling to sustain to ensure sustainable abstraction. And then you can build the water treatment, and then you set up a monitoring program to monitor the parameters, right? To ensure that the model has calculated correct and so on. And then maybe you need to adjust after some years. And it's not like suddenly the parameters change drastically. That will normally be very, very slow trend. So you have time to adjust your abstraction or whatever. But it's important to set up a monitoring program when you're pumping and abstracting, and that's need to continue all time.
Okay, the next is, what type materials is commonly used for your distribution system to prevent contaminations from pipe bursts?
The main pipe system that we use nowadays is HDPE.
HDPE.
Sure. So, so we have, but of course we have older pipes. Almost anything is still there in a limited quantity. PVC and cast iron and maybe even some AC pipes are there locally. But the question is, to prevent contamination from pipe bursts. Now, of course, the more pipe bursts you have, you get more contamination risk, because you have to take pressure off the system. But generally, when there is a pipe burst, we have very, very detailed procedures to avoid contamination. So the section with the pipe burst is isolated, and then the pipe burst is repaired. And then it is flushed before it is again put under pressure. And normally we flush until we can believe that it is clean. So normally we have very few cases of contamination in connection with pipe bursts because of the procedures involved.
Okay, he's continued asking, what is the pressure maintained in the pipeline?
I am not sure I can give you the specific amount in bars. I mean, I think typically it is maybe, you know, Chris, 1, 2, 3, 4 bars. But the thing is to always have positive pressure, so that if you have small leakages, you don't get seepage into it. now in Malaysia, and I know that, of course, personally, pressure disappears every now and then in the system, and it doesn't generally in Denmark. So that's why we have very little contamination through leakages, because the water is always flowing out through the leakage, not into the pipe.
Okay, generally, what of the tube well in Denmark?
So sorry, what?
Generally, what is the depth of the tube well in Denmark? How deep is a well in Denmark generally?
Yeah, Michael, you probably can answer, but I mean,
Yeah,
I think it's less than 100 meter in Denmark generally.
Typically, but we also do have some. I have just made an assessment of a test pumping of a well field with 6 wells, where the top of the screen was typically 160 meters. So it does happen.
Yeah.
I think the deepest I've heard is around 250 meters depth.
Yeah.
But most of them, as you say, Dennis, are less than 100 meters, and most of them are more than 30 meters.
Yeah,
so 30 to 100.
Yeah, that is Denmark. That is in Denmark, but in Malaysia, generally, is 100 to 150 meter. It's very common, very common.
Yeah.
Mr. Wu is asking, how is the groundwater quality in Malaysia compared to Denmark? Groundwater quality in Malaysia compared to Denmark?
I think it is, I mean, it's a very general question. What I have noticed from where I have worked, one of the main differences is that, especially in tin mining areas, you may get very, very high iron manganese. I have seen ridiculously high iron concentrations near or in old tin mining areas. I think the highest I've seen is 70 milligram per liter of iron, and that is never ever seen in Denmark. It's because of the tin mine, of course, but also because the groundwater temperature is higher. It's 26, 27, 28 degrees Celsius in Malaysia, and only 8 to 9 degrees Celsius in Denmark. So you can, the solution of iron can be more.
I think that very much depends on what kind of aquifer we encounter, what kind of formations on the ground that we encounter, because certain kind of give you a very good quality, certain formations give you not so good quality.
Correct.
Okay, I have the last question here. You say in Denmark, may I know
the production cost per cubic meter, right?
Yes, it was the question.
Yeah, I can give a shot on this one. I think in general, the total cost for both water production and sewage treatment and so on is a little above $10 per cubic meter, American dollars.
The cost.
I think that's a selling price, Chris.
That's a selling price, right? Yeah. And the main majority is actually for the sewage treatment also. And as I recall, the production cost is probably less than $1, or maybe close to $0.50 for production of groundwater. But then also the investment in general in new well fields and so on is more or less the same level. So for the future, so I think maybe the production cost is maybe 75 cents, but then if you include the investment for the future, maybe $1.50 for the groundwater, and for the water supply, for drinking water. Yeah. So, and then on $10 also include tax and so on. I mean, all this groundwater mapping is also financed by the water price. Everything is financed by the water price.
Okay, good. I think we have used all the questions that pose into this page. Dennis, can I put it over to you?
Yes. Well, thank you, Dennis, Michael, Chris, for your invaluable contribution today. Especially, I know you have taken a lot of time to prepare for today's session. Dato' Kade, are you there? Thank you, Dato' Kade, and the Malaysian Water Association for hosting today's. Thank you, Dato'. Thank you, MWA, for hosting today's webinar on groundwater. Last but not least, we want to thank all our audience for joining us today. For all our panelists, do you have anything else you want to add? If not, I will close today's session.
I think for those audience who pose some questions that we cannot give the detailed answer now, he can always contact us email to us or contact us so that we can sit down and discuss with him on the solutions for his problem as far as groundwater. We are really
for our participants, you can email to OCNED or you can just drop a message on our Malaysia International Water Convention Facebook page, and we will facilitate to connect you. So ladies and gentlemen, next Tuesday, we will be hosting another webinar, and our topic is construction contracts and the aftermath of the MCO. This webinar will cover the likely construction disputes that will arise following the MCO and the available dispute resolution mechanisms. Our speaker is Ms. Christine Cho from Ma Wing Kwai and Associates. They're a reputable law firm. So do join us again next week for some new insights. And remember to follow our Facebook page. So if there's nothing else to add, we want to thank all our participants today. And please remember to join us again next Tuesday. Gentlemen, thank you very much. Chris, Mikael.
Thank you very much.
Okay, thank you very much.
Thank you, Dato, Mr. Lee.
Thank you very much.
Thank you.
Yeah.
Thank you all very much. See you again next week. Have a very good evening.
Thank you.
Bye-bye.
Thank you.
Thank
Bye.
you.
Pleasure.
Bye-bye.
Thank you.